Okay, so here we are, 31st of the 12th, trying to get year one finished this year. And we are on Stats and Mechanics, Chapter 11, Challenge Questions. Challenge Question 1. Here we go. Particle starts at rest and moves in a straight line at time t seconds. After the beginning of its motion, the acceleration of the particle is a given by, so we've got a equals 3t squared minus 18t plus 20. And we are told t is greater than and equal to 0. Okay, find the distance travelled by the particle in the first 5 seconds of its motion. Okay, so find distance. So find s at t equals 5. Okay, so if we have the acceleration, we can integrate it to get us a velocity. We can integrate that to get our distance. So let's have velocity is equal to the integral of a by dt, which means it's the integral of 3t squared minus 18t plus 20. Okay, which would give us increase the powers here. So we will have what am I writing? Increase the powers and divide by the old powers. So 3t to the 3 divided by 3 minus 18t squared divided by 2 plus 20t plus c. Work that one out at a second. Okay, so velocity is equal to t cubed minus 9t squared plus 20t plus c. Going back to initial question, a particle starts at rest. So that means velocity was equal to 0 when time was equal to 0. Okay, so that means we can put in all of these ones and get a c equal to 0. So we get rid of that first constant. There we are. Right then, so now what we can do is we can say distance is equal to the integral of velocity in terms of time, and we can look at the integral of t cubed minus 9t squared plus 20t. Ignore the plus c because it's plus 0, and so we get t to the power 4 over 4 minus 9t squared, no, not squared, cubed, over 3 plus 20t squared over 2 plus c. And so we can say this is equal to, the distance is equal to t to the power 4 over 4 minus 3t cubed plus 10t squared plus c. What do we have in our initial conditions? At time t seconds after the beginning, it is in motion. The acceleration of the particle is a. So we know again that it has travelled 0 distance for 0 time. So when we substitute 0 into all of these t's, I'm not going to write it out, we just get c equal to 0. So we've now got a distance formula plus what looks like hot there, but it's actually 10t squared. Okay, and they wanted to know the distance when t was equal to 5, or the distance after 5 seconds. So let's start putting that in. So we've got 5 to the power 4 over 4 minus 3 to the 5 cubed plus 10 to the 5 squared. And so chucking all of that into a calculator. So a quick look. 5 to the power 4 over 4 minus 3 times 5 cubed plus 10 times 5 squared. All right, is 125 over 4. 125 over 4, which is 31.25 meters a second. We were doing distance, just meters. Okay, 31.25 meters. Done. One question to go. All right.